Quantum mechanics is a baffling subject with a lot of seemingly impossible things. One of these is quantum entanglement, where it seems like two particles are communicating with each other as if by magic. Of course, it's not magic, it's science. Sounds confusing, doesn't it? Well, let's fix that. Before we get into quantum entanglement, first we have to talk about correlation. Correlation is where the state of two things are bound together, like these two coins. As you can see, these two coins are physically bound so that the state of one coin is correlated to the other. The one on the top is heads and the one on the bottom is tails. And the opposite is also true. When the top is tails, the bottom is heads. So if I measure one, I will know automatically what the other is. Now, if I were to take these two coins and put them in a cup and shake it like this, both coins are now every possible value at once. This means that until I stop shaking them, both the top coin and the bottom coin are both heads and tails. This is what is called superposition, and as long as the coins remain in superposition, they are every possible value at once. When I measure them, they stop being in superposition. Now that they're not in superposition, a value has been chosen. I know that if one is heads, the other is tails. Now, quantum entanglement is the same, but instead of the particles being bound physically, it is their quantum state that is correlated. Correlation requires the particles to be interacted. Quantum entanglement is what happens when you have two particles that are interacted and then separated again. These two quarters are my two particles. I've interacted them and separated them again. Now these two particles are in superposition, just like the earlier coin and the cup. When I measure them, they stop being in superposition. Now what's really cool about these particles is that they can be on opposite ends of the table, or they can be light years apart, and they would still interact in the same manner. So when I know the value of one, I instantly know the value of the other. This is what Einstein called spooky interaction at a distance. Einstein did not believe that this was how quantum entanglement really worked. He believed that the particles had a predetermined plan that was hidden from us until after measurement. As Einstein's theory made sense, and there was no way to prove otherwise at the time, scientists generally accepted this idea, at least until Bell came along with a way to experiment and prove it correct. Bell calculated what the percentage should be if the state was predetermined and ran his experiment multiple times. The results of the experiment should have agreed with the math. However, it did not, and instead agreed with what quantum mechanics said it should be. This ultimately proved the quantum entanglement theory right and Einstein wrong.